Let's talk about the domain of a function. And in this video, we're going to talk about finding the domain from an equation, not from a graph of the function. So the domain of a function is all of the possible x values that are allowed to be entered into that function. So if we consider the function f of x equals x plus 5. Consider the possible values that we could substitute into this function. Let's say x equals 0. 0 plus 5, that would equal 5. Or x equals minus 3. Minus 3 plus 5, that would equal 2. Or x equals negative 0.864395217 plus 5. It doesn't matter what value we substitute in. I don't know the answer to that decimal one off the top of my head, but we can substitute any value in for this x. There's no value that we can't put in to this sort of function where we have f of x equals x plus 5. So functions like this have a domain of any possible real number. So we could put anything as small as minus infinity up to positive infinity. So the domain for this function is domain from minus infinity up to positive infinity. This is using our interval notation, which there is another video to have a look at, and I've popped the key or the tag to find that up here at the top right hand corner. So the domain for this function is minus infinity to infinity. We can put any values into that function. But there are some functions where we can't enter some values. Consider what we know about division. Is there a possible value that we're not allowed to divide by? We know that if we divide by x, if we divide by 0, we'll have an undefined solution. So let's consider the function f of x equals 1 over x. If I tried to substitute in x equals 0, we would have f of 0 equals 1 divided by 0, which we know we can't do. There's no solution for that. Another way to think of it is if we try to divide by 0, we break maths. We break real maths because we don't have a solution for dividing by 0. So what that tells me is the value 0 is not in the domain of this function. So the domain is all of the values except for x equal to 0. So the domain is everything except x equals 0. So x cannot be equal to 0 for our domain. Any other value we put in here, no matter what it is allowed. We can divide by positive numbers, negative numbers, whole numbers, decimal numbers, irrational numbers, rational numbers. Anything can be divided except 0. We can't divide by 0. So if we have a function with a fraction in it, we need to be careful that we don't end up dividing by 0. So that's one of the first places where we can have some restrictions on our domain. So up here, we'll write the restrictions on domain. We can't divide by 0. We know that. That's one of the things that kind of breaks maths when we try and divide by 0. That's the first restriction on our domain. So let's have a look at some functions. Get rid of these, don't need those anymore. Some functions where we have to consider this restriction on our domain. So for example, the function f of x equals 10 over x plus 3. Now here we could substitute 0 into the function because we'd have 0 plus 3 equals 3, and that's okay. The only thing we can't have is we're not allowed to have the bottom equal to 0. The denominator cannot be equal to 0. So x plus 3 cannot be equal to 0. So we need to know what x value would make it equal to 0, and then that value is not allowed to be in our domain. So if x plus 3 cannot equal to 0, let's find out what x value it's not allowed to be equal to. We can treat this cannot be equal to symbol just the same as we would an equal symbol for solving equations. So we would subtract 3 from both sides. And x, I cancel over here, cannot be equal to minus 3. So if we check, if we were to try to substitute in minus 3, we'd have minus 3 plus 3, and that would equal 0. So our domain for this function is any number you want as long as it is not x equals minus 3. Minus 3 is not allowed or not equal. It's not allowed to be in our domain. So we can have any other value except for x equals minus 3. So the domain is x not equal to minus 3. Everything else is fine. But if we put in minus 3, then that would be dividing by 0, which we are not allowed to do. have a look at, for example, the function g of x equals 10x plus 4 over the top of 13 minus 2x. Having a look at this function, we have x's in both the numerator and the denominator. But the numerator is like our first equation. We could substitute anything into the numerator. The only thing we can't do is try and divide by 0. So that means our denominator cannot be equal to 0. It doesn't matter what's happening on the top as long as there's no square roots, but that's the next restriction we'll look at. But if we just have a simple fraction, we can't have a denominator of 0. So what that tells me is 13 minus 2x cannot be equal to 0. It's not allowed to be equal to 0. So let's plus 2x to both sides to make that positive. And we have 13 cannot be equal to 2x. Divide by 2 on both sides. And that will tell me that x cannot be equal to the fraction 13 over 2, or 6.5. Because if we have 2 times 6.5, that's going to be 13, and we'll have 13 take 13, which will equal 0. So my domain for g of x is all the values except for 13 over 2. X is not allowed to equal 13 over 2, or 6.5. When we have a fraction, to find out the values that aren't in the domain, we set the denominator not equal to 0, because we know it can't be equal to 0. So to find out what's not in the domain, we make it not equal to 0, and so x cannot be 13 over 2, and in this case, x cannot be minus 3. That's talking about our restriction when we have fractions or trying to divide by 0. We have a second sort of restriction. So let's clear all of these ones and look at our second sort of restriction. So the first one is when we have a fraction. The second one is, like I said before, when we have a square root or a third. Whoops, a little bit far down before. There's some functions. There we are. So for example, the function f of x equals square root of x. We could put 4 into this function. We know the square root of 4 is 2. We could put 9 in. Square root of 9 is 3. We could put 1 in. The square root of 1 is 1. We can put in a fraction. We can put in a decimal. Square root of 0.5. Square root of any value, as long as it is positive. We can't take the square root of a negative number. So, for example, we can't have f of minus 2, because that would be the square root of minus 2. The problem with this is it is not a real number. It is an imaginary number, but we haven't dealt with those yet. So once again, we'll assume that we're breaking real maths by trying to have square root of a negative number. So our first restriction was we can't divide by 0. Our second restriction is we can't have a negative under the square root. Doesn't matter what else is going on in the function. If it's got a square root in it, we have to make sure we do not have a negative underneath the square root. Those values won't be in our domain. So considering this first function here, we know that our x value has to be 0 or greater. We can take the square root of 0, that's just 0. But as soon as we get a negative under the square root, then those values are not in our domain. So what that tells me is all of the x values have to be greater than or equal to 0. Let's see if we can remember how to write that in interval notation. The minimum possible x value we can have is a 0. And because it's equal, greater than or equal to 0, we can use a square bracket to say that 0 is included. Maximum possible value would be infinity. We can go all the way up to positive infinity. And we use a round bracket for that because we can never actually reach infinity. There's always something bigger. And so that's, oh, we forgot to write domain. Let me squeeze that in there. The domain of this function is from 0, including 0, up to infinity. As long as we're putting positive numbers or 0 in here, then we're okay. Now it's nice and easy for us when we have f of x as our function. But what about if we have something like, or we won't use f again because we already used that, g of x equals the square root of 2x plus 4. Once again, we can't have a negative under that square root. So this whole part of the function, the little expression under the square root, has to be positive. So we set that as greater than or equal to 0. 2x plus 4 has to be bigger than or equal to 0. And once again, we can treat this greater than or equal sign just as a normal equal sign. Ignore it, work like we normally would solving equations, and then we can go back to it at the end. So first we would subtract 4 from both sides. And we would have 2x has to be greater than or equal to negative 4. Then we divide by 2. And we see that x has to be greater than or equal to minus 2. If we substitute that back into our function, minus 2, 2 times minus 2 is minus 4 plus 4 would give us 0. Something bigger, well, minus 1 is bigger. 2 times minus 1 is minus 2. Minus 2 plus 4, that would be positive 2. So as long as we have a value that's equal to or greater than minus 2, it is in our domain. So if we know all our values have to be greater than or equal to minus 2, we can write the domain. Domain will be the smallest possible value we could have was minus 2. And because it could be minus 2, we use our square bracket. Once again, we can go up to infinity. That's the domain for this sort of function. Let's look at one last function that has a square root in it. We'll use h of x equals 3x squared plus 4x plus square root of 3x minus 2. Now this function has 3 different parts to it. The 3x squared, the 4x, and the square root part. Now there are no restrictions in what we can put into 3x squared. It doesn't have a fraction, it doesn't have a square root, so we can put any values in. There are no restrictions on the 4x. Once again, no square root and no fraction, so we're okay. The only part that's going to have some restrictions on it is the 3x minus 2. There are only some x values that we can put into that square root so that it doesn't end up with a negative number underneath. Because we know we can't have a negative under the square root. That kind of breaks our real maths. So what that tells me is that the part under the square root, just like before, the 3x minus 2 has to be greater than or equal to 0. It has to be a positive number. And so we treat the greater than or equal to sign just like we would an equal sign in an equation to solve the equation, and we add 2 to both sides. And we have 3x has to be greater than or equal to 2. Then we divide by 3, x has to be greater than or equal to 2/3. As long as our x value is greater than or equal to 2/3, we won't end up with a negative underneath our square root. So the domain for this function, the minimum possible value we can have is 2/3, and because it's greater than or equal to, can have 2/3, so we use our square bracket, all the way up to infinity. That is the domain for this function. So it doesn't matter about the 3x squared and the 4x outside of that square root. We can put any values in there, but the possible restriction comes when we look at the square root part. So everything under the square root has to be positive. To find the domain from an equation, we check if it has a fraction. If there's a fraction involved, we know we can't divide by 0. So we have to figure out which values would be making us divide by 0, and they're not in the domain. Or if we have a square root, we know we can't have negative under the square root, so we have to figure out what possible values could we have under the square root by making everything under the square root greater than or equal to 0.